So the question that I have in front of me requires a graphing calculator. So I'm going to go ahead and I'm going to be plugging in this function into my graphing calculator, right? Now, let me look at the graph. And what we see here is basically this weird figure here, right? It's like a valley. This is called the vertical asymptote. It's happening at this x, which is 2. So when the x is 2, we have a vertical asymptote, right? So now we're going to go here and I'm going to look for vertical asymptote at x of 2. Either going to be C or D. How do I know if my function is continuous at x of equal -1 or not? You should go to second table, and when the x is equal to -1, you have an error, right? When x is equal to -1, you have error. Error means my function is not continuous, right? And if my function is not continuous, then the answer is going to be choice D. Okay, so let's just label that. My answer is going to be choice D for question 1. Okay, where choice D is vertical asymptote at x of 2 and a removable discontinuity at x equals to -1. Okay. Let's move on to question 2. We should also be graphing this function. So let's go to y equals, and let's just grab the whole thing. So x cubed plus 4 x squared plus x minus 6, 3 sine negative pi over 2 x plus 3 x squared. Let's graph it and see what's happening. Okay, so nothing looks wrong with the graph, right? But the graph could actually fool you. You have to actually go to second table and look what's happening. When x is 1, we have an error, right? And error at x of 1 means that there's a problem, that my f does not exist at 1. Okay, so my f is not going to exist at 1. So basically a is possible, okay, and b is possible, but c is going to be wrong and d is going to be wrong. F does not exist at 1 because of that error. The question is, does limit exist or not? We can actually tell by looking at the graph. So let's look at the graph, and the graph doesn't have any cut in it. There's no cut, there's no jump, there's no vertical asymptote when I'm talking about x of 1. There's nothing in the graph that's wrong, and so the answer here is gonna be choice B. Okay, there's nothing wrong with the graph, the limit exists, but we looked at the table and there was an error, and error means that my function would not exist. All right, moving on. Now let's move on to question 3, also a graphing calculator. Let's graph this function. So y equals, let's do the function. So we're going to have x cubed minus 9x over x cubed plus x squared minus 8x minus 12. Let's graph it. Okay, we're looking at x of minus 2 and x of 3. Let me expand my window. I'm going to make it as small as minus 3. I'm going to make it as big as 4. You should always have less than the minimum and more than the minimum. So like if they're asking for x of minus 2, make your x min minus 3. If they're asking for x of 3, make your x max 4. Let's graph it. Okay, I do see a problem with my graph. I think it's very obvious. We can all see that. Let me show you. So here I have this weird thing again, the valley, which is a vertical asymptote, which occurs at this x. So it's occurring at x of -2. Okay. So I have a vertical asymptote at x of -2, which means my answer is going to be either C or D. Right? Okay. Now, let me see. At f of 3, if f is continuous, then when I should look at the table, I should not see any error. I'm going to go to second table. When x is 3, I do see error. That means my function is not continuous at 3. It's not. And so it's not continuous at 3. And so my answer is going to be choice D. Okay. Moving on to this one here. Again, we're going to be graphing it with our graphing calculator. So I'm going to go to y equals. Let's make the numerator denominator thing. So x cubed plus 2x minus 12, 8 cosine pi over 2x plus 2x squared. Let's graph. Okay, now I do see some weird things in my graph, but there's no vertical asymptote mentioned in here. Okay. Now, they're saying, does f of 2 exist or not? Again, I could look at my second table, and when x is 2, I have error. Because I have error, that means that my f of 2 does not exist. Okay, my f of 2 does not exist. So that means that the answer is going to be either A or B. The question is, when x is approaching 2, does my graph look weird? Here we have x approaching 2. And my graph looks pretty normal. There's no breakage in it. There's no vertical asymptote. So my graph has a limit. My limit does exist, okay? My limit does exist, but simply that my f of 2 does not. So I'm going to erase that one, right? Because A is wrong, right? B is going to be the right answer. My limit exists, but f of 2 does not exist. Okay? So here we have application of the IVT. And for the IVT to work, you have to basically know the following condition, that C is bigger than A but less than B. F of C is less than F of B but bigger than F of A. And this is going to be RA, and this is going to be RB. So that means that I must pick a value C that's bigger than 24 and less than 28. I must also now do the additional thing of finding how much is the f of 24, so that the f of C is bigger than that, but less than the f of 28. Now it's time to use our graphing calculator or any calculator to find f of 24 and also f of 28. Now I'm going to be using my graphing calculator to find the value when x is 24. So 9 plus 2, and then instead of, I'm going to put x in here, and then I'm going to put e, and then power. I'll plug in my function first, and I'm going to be plugging in the values. That's better. That's better for the future. You will see why. Okay, cosine, and now alpha, second pi, or is it? It's actually x, sorry. X over 2. Okay, now, that's my function, right? Now I'm going to be taking it by pressing on enter. I'm going to be replacing each x with 24. So I'll also go here and replace it with 24. And then I'm going to be having here e the power. Okay, I'm gonna replace also the x here with 24. Let's see how much that is. Click on enter. So my least value is gonna be 10.806. This is gonna be the value of f of 24. Now it's time to do it for the f of 28. So what you do is you copy paste this function and just replace the x's with 28. So I'm gonna replace this with 28. This one here with 28. And this one here with 28. Click enter. My maximum value of f of 28 is going to be 66.193. Now, my answer has to be ranging between 10.806 and 66.193. So my answer has to be between those two, and that is going to be choice C. So here I have application of the IVT, and for the IVT to work, I have to have to satisfy the following conditions. That C is bigger than bigger than A, less than B. F of C is less than F of B, but bigger than F of A. Now this is the A, and this is the B. So right now my job is to one time plug in 10 in the F and one time plug in 12, and I must surround my F of C between those two values. Now it's time to use the calculator to find what F10 is about and what F12 is about. So my F of 10 has to be 29.544 and my F of 12 has to be 6207. That means my F of C has to be bigger than this and less than that, and the answer is going to be choice C.